All right. So this is going to be a fast review of logarithms. You guys have been doing logarithms every day since you stopped intermediate algebra anyway, right? I'm joking around. All right. So remember what we learned about how you go into and out of the log world, right? I said when you gain or lose. Is that making sense what I'm talking about when I say that? So when there's not a log there, and then you put one on, that's called gaining a log, right? Or when there is a log in the original question, and you take it off, that's losing a log, right? So when you add in a new log or remove a log that's already there, when you gain or lose a log, what do? The base stays the base, and the other two switch. That's the fundamental log rule. Base stays the base, other two switch. So they're asking me on these to convert to a log. So they want me to bring...
Sorry.
Are you beeping, Michael?
Yeah.
Okay. So I'm going to bring in a log word here. So they want me to bring in a log word that wasn't already there. What happens when you bring in that log word? The base stays the base. Now, who's the base? Who's the base in this current setup? Who's the base here? Well, a base is something that has something on him, right? It's the 3. That's the base, right? The base is the 3. So the base stays the base. He continues to be a lower down. Base just means bottom. Has something on him, right? It's the bottom part. So the 3 will continue to be the low down. That's why we lower something down. When we write logs, they have that lower down number. The base stays the base. The other two, what other two? Negative 2 and 1/9, they switch. So instead of 3 to the negative 2, it's 3 to the 1/9, and the negative 2 goes over there. That's all they want. At first. They'll want more later. But for now, they just want us, we're just going saying 1 and then uno, right? We're just saying the same truth in 2 different languages. We're just translating between non-log talk and log talk. Back and forth. Okay. So let's begin. So if you have your calculator, take it out. We're going to take the log on this one. They want us to take, what is that? Is that 10,000? How many zeros are there? It looks like 10,000 to me. 4 zeros? Yeah. So the log of 10,000. Let's just hit the button on the calculator. You guys have that with you? 4. Yeah, the answer should be 4. It basically gives you the number of zeros. Log of 10,000. If you have your calculator, hit log of 10,000. And you should get the answer 4. Everybody able to get that? I'm glad to help if you have trouble with the calculator. Not that fancy thing again. You haunt me, man, with that 89. Those are always so hard. Isn't there like a basic screen for entering stuff? I mean, that's not the 89. That's usually how I handle it. I grab somebody else that has 89. The fancy, high-powered TI-89? No. You're low.
Good. Don't get it.
Don't get it. It's like a mini computer. It's like super powerful. But that makes it, you know. Calculator, you hit that. Yeah, there you go. That's it. I think. It's right down there. See if it works out. Log of 10,000. Yeah.
Where's line?
I don't know. I can help you later, maybe. Yeah. So log 10,000. You guys getting that? 4 on that. All right. So that's just hitting the buttons. Let's try that. So log base 5 of 625. Now you don't. Excuse me. You don't have a log base 5 button. So what you have to do this one is turn it into 2 logs. Everybody tracking with me? So turn this one into 2 logs. The last one, we only had one number, right? Just 10,000, so we just did the log of 10,000. But this one, there's 2 numbers, so you have to do 2 logs on your calculator. The high goes high. A lot of times students will ask me, how do you know which one goes top or bottom, whatever, or first or second? Just remember, the one that's lower down, lower down the base number, the 5, that goes to the bottom. So the bottom goes to the bottom, the higher one goes high. So the high goes high, the low goes low. Hit the button. Isn't it like 3? 4? 4. It's 4 again. Right? Is it 4? Yes. The answer is 4. That's the thing. Logs always come out 4. No, I'm kidding. They don't always come out 4. Yeah. What's that?
You'll do log 65 divided by 1.
Right, but you got to make sure you don't you separate. I mean, I'd be glad to show you, but that's not what you're going to use in the test, right? So, so type it in on the calculator. On that, I encourage you to bring the calculator. Oh yeah, today. Yeah, I should make that announcement. Today's the calculator grab day. If you want to do that, right? Today's the day. So if you want to grab a calculator to rent. You can do it to test, to get used to it. We good on that? Questions on that one?
Yeah, I had a question. Why would you divide 625 by, or log 625 by log 5?
Yeah, I didn't give any logical reasons for that. I would be glad to. Grab me after class. There's a whole mathematical proof, and I'll be glad to show it to you. Okay, so do you have your calculator hit ln of 1 should get 0. ln's a different button. It's stands for natural log. It's said backwards. It's logarithmic natural log backwards. So natural log of 1 is 0. We good? You getting that? Okay, with the natural log button. So they're just making sure you can hit the buttons on your calculator, like that. All right. Yes. Okay. All right, so I don't know if you remember much from intermediate algebra about logarithms, but there's 4 properties. 4? No, there's 3. There's 3 properties of logs. So let me just write the 3 log properties. Maybe some of this will come back. So the log base b of x times y. Anybody remember? Multiplying for one log becomes adding, right? For 2 logs. And that's the first property. And, dividing for 1 log becomes subtraction for 2 logs. And lastly, powers come down to the front. Okay, you need to know those like the back of your hand. We'll use those like crazy. In the log, whenever we do logarithms, we're just always using those properties. Those are 3 weird, kind of special properties of logarithms. You can put those in your 3x5 card, right? You get a 3x5 card you can use during the test. But really, it's good to just know those. You use them so much. You got to kind of get to know them, probably. So let me help. How do you handle when somebody throws a bunch of math formulas at you, or science formulas? What's a good way to memorize them? Part of memorizing them is noticing what's not changing. Notice they all have log base b. They all have a log b. So that's not something you got to remember, right? It's log b, log b, log b. They're all log b. We're not doing anything with the base. It's like it's permanently glued to the log word, right? That's not what's changing. What's changing is the arguments that come afterwards, the plug-ins that come afterwards. So x times y becomes adding, multiplying becomes adding, dividing becomes subtraction, and powers come to the front. I don't know if you ever spend much time thinking about. Let me say a couple things that might help you kind of get that the concept of those rules. If you get the idea, the memorization becomes easier. What's the first math thing you did when you were a kid? First kindergarten, first grade, first math operation you ever did? Adding. You started adding, right? And then later you started subtracting. Then you got a little older. Math seem great in those days. Adding, subtracting. Then you got a little bit older, and it was multiplying and dividing, right? And you got a little bit older, and they did like powers and stuff, right? Those 3 operations, if you think about it, those 5 operations are in a hierarchy of 3 levels, if you think about it. Meaning this. Every level repeats the last. In other words, multiplying is repeated adding. You know that, don't you? What is 2 plus 2 plus 2? It's 3 times 2, huh? Multiplying is just repeated adding, isn't it? And dividing is repeated subtraction. What do I mean? If you take 8 divided by 2, right, the answer is 4 because you can subtract 2 from 8 4 times. It's repeated subtraction. Dividing is repeated subtraction. Multiplying is repeated adding. And powers are repeated multiplying, aren't they? What's 2 to the 3rd power mean? But repeatedly multiply. Okay. So what? Well, logs bring everybody down a level. That's what they do. I can tell you all those properties by going, logs bring them down a level. That's all that's saying. If you understand the hierarchy and the levels, logs bring everybody down a level, right? Multiplying becomes adding. Dividing becomes subtraction. Okay? And powers become multiply. Brought it down a level. logs bring everybody down a level. And like operations go with like operations. What do I mean like? Multiplying's like adding. They both make things bigger. Dividing's like subtraction. They both make things smaller. Right? And powers is like multiplying because it's repeated multiplying. So logs bring everybody down a level. Not only that, one more thing to help. The easier operation is always for the 2 logs. 2 logs. What do I mean? Adding for 2 logs, that's easy, right? Adding's the first thing you ever learned in math, the easier operation. But it's a harder operation for 1 log. It's times. So that's like, I'm just thinking of an old saying. Like the old saying, they say, many hands make the job lighter. Like a lot of people working on a job makes it easier. That kind of works for our log memory thing. If you have 2 logs, 2 people working on the job, it's just adding. It's easy. Whereas if you have 1 log, it's multiplying. It's harder. Same thing for the next one. 1 log dividing. You get 2 logs on the job, that just becomes subtraction. It's easier. So whenever you're looking at those rules, that's the fundamental thing. 2 logs, easier operation. 1 log, harder. It brings all the operations down a level. That's basically what the log properties say. Okay, so they're giving me this one. 2 logs subtracted. So 2 logs, easy operation like subtraction, easy for 2 logs, is going to be a harder operation for 1 log, right? It's going to be log base b. And what's going to be the operation for the 1 log? Subtraction goes with dividing. 19 over 9. We're done. It's this one. Good on that? Makes sense? So subtraction becomes dividing. All right. Okay, so we have 4 log base c of x minus log base c of y. They want me to express as a single log. They're saying, hey, take those 2 logs and smash them into 1 log. Make 1 log out of them. Crunch them together. So here we go. Log base c, the base never changes, right? So that's just automatic. Log base c. So what am I going to do to make those into 1 log? Well, the number in the front, where does he go? Power. Remember that's the third property. Numbers in the front are powers. So this is going to go right there. And then the subtraction becomes divide. We're done. Is that good to there? Questions on that one? Make sense how I did that all in one step? Okay. Okay, so log x to the 9th, y to... By the way, this one has no base. You notice that? There's no base showing. There's no low-down number. If there's no base, really that means the base is 10. Every log has a base. If it's not showing its base in, you don't have to write that in, though. Don't even write it. Don't even bother with it. I just want you to know there is a base 10 there, but we don't have to do anything with it. All right, anyway, can you do that one? What do they want me to do? Write as a sum or difference of multiple logs. You get the idea. Basically, if they give you 1 log, they want you to make it more than 1 log. If they give you more than 1 log, they want you to make it 1 log. It's just back and forth. They're just playing the game back and forth. So here they're giving me 1 log. Can you make that into 2 logs? The last problem, they gave me 2, and I made a 1, right? We're just doing the properties back and forth. So let me let you try that. This class is hard. I think I said that in the first day. This class is hard. What's hard about this class is we do a lot of algebra 2, a lot of the harder parts of algebra 2, exponential functions, log functions. Today we're going to do both of those. And there just isn't time for me to teach it like it's brand new to you, because they just cram it in, hour and 15 minutes. I've got to go through what I would spend 2 weeks on in Algebra 2, because that's first time for them. So I'm saying all that to say, but I know the reality is I've taught this class enough times to know most people come in not with those things on the top of their mind, I'm glad to help you. Come to office hours. I'll be able to go slow. I'll go as slow as you need. I'll help you with this stuff. Go to the tutor. Today he's coming in at 2 o'clock, Roberto, or soon after. Roberto's our class tutor. He knows all this stuff. You need to master this section and the next, and I'm really not going to have time to do it. It's a prerequisite of the course. They assume you really already know this. And not that I want to lord that over you or something, but I have to. because there's a bunch of other stuff I have to get through. I can't spend a week on this. So having said that, I know I'm going to fly fast over many of your heads today. But come see me, see Roberto, go to the tutoring center. There's tutoring even in this building. Did you see that? Have you seen the flyers that are around, like on my office just down the hall and most of the offices? There's a little flyer. Did you guys see that? That says, there's 3 kinds of tutoring on campus. There's the tutoring right in this building. Those little flyers, just look around the hall there, you'll see them. It says different hours. There's almost always a math teacher at those and a tutor. Go to those. Those are helpful. Go to the general tutoring over in the library building, right? They're open like 8 to 5, except for Friday. They're done by noon or something on Friday. And then the best is going to be Roberto, who should be in here within a half an hour. He's just for us. Like, he'll teach you the same way you're seeing me do it. So that's the problem with tutoring, right? Sometimes you get a different way. Roberto will show you. He'll be dialed in with me. He already has been, seeing the ways I'm using. He'll show you the same way, and he'll give you some hours where he's available. So, having said that, most people can't make it through this material without help because they don't remember all the prerequisite stuff. All right, so the 9 goes in the front. You separate them into 2 logs, and there's our answer. So the powers go to the front, and the multiplying, where's multiplying? Well, it was understood to be multiplying in the beginning, huh? Becomes adding. Easier operation for 2 logs. Harder was for 1 log, right? It was times for 1 log, just adding for 2. Powers go to the front. Make sense on that? So speak up if you want to talk about it. I'm glad to help what I can in this quick overview. Okay, so we have log base 2 of 2y over z. They say, you can tell they're breaking it into 3 logs. So go ahead and give it a try. It's not going to be multiple choice on the test. You know you guys know where I showed you where my practice exams are, right? Right up there. Haven't I? Yeah. Yeah, the first page of Math Excel. Anyway, take a look at the practice exam. You'll see it's not multiple choice. So I'll just give you this question and say, just give me the answer. So make sure you can do that. So give that a try. Break it into 3. So it's going to be log, the log base 2, that's not going to go anywhere, huh? And then there's 2, there's y, and there's z. The first 2 are added, the last one is subtracted because it's divided. Is that good? So dividing, things in the denominator become subtraction, don't they? We good with that? Easier operations for several logs, adding, subtracting. It's just easy stuff for lots of logs. Hard stuff for 1 log. Question?
So the 2y doesn't stay together because it's multiplying?
No. So the 2 is just like an x or something. What if I give you x, y, z? You'd separate them. Yeah, 2 is just another piece of the puzzle. Yeah, just separate them all out. On that one. We good with that? That makes sense? Question?
Yeah, so we're multiplying the y because it's multiplying log 2. Log 2 is multiplying 2y.
Up here, you mean? Yeah, there's times?
Yeah.
Yeah, because the 2 and the y are right next to each other with nothing in the middle. That's times. The z is dividing.
So that's why we're adding and then subtracting.
Yeah, adding between the 2 and the y logs, subtracting with the z. Exactly. All right. So whenever they just give you 2 numbers like that with a log, just remember the high goes high, the low goes low, hit the buttons. What is it? It's 1 point something.
9037.
9037. They want 4 decimal places. What was after the 7?
It was actually 9036747.
Right, so you rounded it perfect, yeah. Right, that good? So if they just give you 2 numbers, the high goes high, the low goes low, just do it that way. They'll show some other fancy, this is way easier. Just hit the buttons on your calculator. Like that. So they're just doing a quick run over of everything you learn about logs in intermediate algebra. So y, let me move it down here. So y equals natural log of x plus 2. They want me to graph it. I would suggest just make a table, xy table, do a couple of points, So let's just make an xy table. Remember doing that in your algebra days? You make like an xy table, you plug in some x values. You can. What x value should you plug in? Anything you want. It doesn't matter. How about 0? 0 is usually an easy number. How about 1? Just hit the buttons on your calculator. You just need a couple of dots. So, you need a couple of dots and to know generally what natural log looks like. Let me tell you generally what natural log. It generally looks like that. Natural log generally will look like that. Now, they might flip it or move it left or move it right, but it's going to generally look like that, meaning it takes a dive. Natural log always takes a dive somewhere. Climbs. See how it's like a bowl turned down? It climbs slowly and takes a dive somewhere. That's what you're expecting, something like that. So with that in your mind, you can just put that in your 3x5 card. With that in your mind, if we just get a couple of dots, we'll be able to tell what the graph looks like. So how do we get those dots? We'll just plug in 0 and 1. So plug in 0. That's natural log of 2. So we have that, is that the decimal, huh? 0.678, I don't know. Somebody have natural log of 2? Well, I got my graph calculator here. Natural log of 2. Okay, I'm getting 0.69. I'm just going to say 0.7. That's as accurate as I could graph anyway. It's 0.7. And then I'm going to plug in 1. So that's natural log of 3. And that's 1.09. Or I'm just going to say 1.1. That's as accurate as I could graph anyway. We good to there? Okay, so now let's put those points on the graph. Over 0, so here's 1, 2, here's 1. Over 0, up 1, over 0.7. It's about right there. About right there, maybe. Over 0, up 0.7. And over 1, up 1.1. It's about right there. This one is over 0, up, well, up 0.7, isn't it? Whoops. I messed that up. Over 0, up 0.7. So, and you know it goes like this, because I told you it's bowl turned down. This right here? It's a 1? Yeah, it's a parenthesis and a 1. Yeah, because that's over 1, up 1.1. Everybody see how I found those two dots, right? I just plugged in 0 and 1, hit the buttons on my calculator, and so then it's over 1, up 1.1, over 0, up 0.7. Connect the two dots with a bowl turned down. Notice I did not connect the two dots. I didn't put the two dots and go, oh, here's my two dots, like that, because I knew that's not how natural log looks. Natural log is a slow growth function. That'd be a bowl turned upwards, wouldn't it? That's not what he does. So you need to have the general knowledge of what natural log does, bowl turned down, and then a couple of dots. Can you tell which answer it is? It's A or D, isn't it? Yeah, it looks, well, how can you tell if it's A or D? I don't know. Yeah, it looks like D to me as well. Anyway, it's not multiple choice on the test, so this is good. This right here is plenty good enough for me on the test. Just two dots, general shape, I'm good. Makes sense? Questions? All right, so 22. This will be representative for all those. So they're giving me this big, ugly function thing here. And they're saying, okay, x equals 1 is the year 2001. Remember how they always set these up for time, you know? So that means like x equals 2 would be 2002, and x equals 10 would be 2010, etc. Get the idea? So, all right, so now they're saying, what is the expected percentage of people who are 60 or older in 2004? So this is one of those, this is something that like Social Security and other organizations, medical establishments are constantly doing. You know, our aging population, right? Our population's getting, on average, older and older, right? There's less and less young people, more and more old people. Social Security is going to collapse, they say. Anyway, so this is these kind of calculations. Like, what percentage of the population will be 60 or older in the year 2004, in the year 2014, 2031, 2048? So using this function, so what they do is they chart some data for a while, and then they jump into the future, assuming the trend continues. Right? That's how social scientists would do this kind of thing. They would use math to predict the future. But it's all based on the assumption that the trend continues. Okay, so here we go. G of x equals 13.65 plus 562 natural log x. Okay, so they want to know in the year 2004. How do we do it? What do I plug in? Yeah, just 4. Remember how we, like over here, we said when x is 2, that's 2002. So when x is 4, that's 2004, right? So they just want me to take a 4 and plug it in. So that's g of 4, in other words. So use your calculator and plug in a 4 there. Okay, so anybody got it?
17.2.
17.2. Let's see if I get the same thing. 2.65 plus 2.62 times natural log 4. Yep, 17.2. Now, what is that? That's the percent of our population that will be 60 or older, or at least was back in 2004, since this is 2016. Right? So that was back in 2004, 17.2% of the United States population was 60 or older. That's going to be growing over time. They said round to the nearest 10th, so that's perfect. That's rounded to the nearest 10th. Now, you could do all the other data points, right? The next question will ask you for, 2014, 2031. So let's do 2040. Let me just jump all the way to 2048. So I'm going to plug in 48 and hit the buttons on the calculator and see what we can get. I'm getting 23.568. We're supposed to round that to the first place after the decimal. 23.6%. Yeah, so that means this formula anyway, according to current trends, is predicting that if things don't change, then in the year 2048, a much larger percentage of our population will be not making money, basically, right? Not contributing, and so the younger folks will have to support us all. So anyway, that's why the people talk about all these kind of things. And Social Security will collapse. Who knows? Anyway, good so far. Now I want to go on to show you the graph part. That's probably a little bit more tricky. So let's do it. But that plugging thing, that's how all these last 5 problems, or whatever it was, 5 or 6 problems are. But let's go on and do the graph thing. Okay, yeah, so if you basically take those data values we got and put them on a graph, I don't even remember what they were now. So here would be 0, that's the year 2000, right? Right, because 1 is 2001, so 0 is 2000. And then they had us do what values? It was 2004, so we went, and eventually all the way to 48. So way over here is like 48, say this is 25. And anyway, so 14's about, what is it, about right here? Here's 2014. Here's 4. 31's about right there. Here, I'll erase the 25. We don't even need the 25. So just put those values on the graph. So what I'm getting them from here: 4, 14, 31, 48. See where I'm getting those? Those are the x values we plugged in to the natural log function thing, right? And the y values are the answers we got. So what were those again when we plugged in 4? What was it? 17.2. And then the next one was, this is 17.2. What was the 14? 20. It was a little higher. And then the 31? 22. It's not much higher. And 22. And then, what was the last one, the 48? 23 point something? 23.6? Yeah, so anyway, you see they just slowly go up. So it's D. It's a slow growth function. That's what natural log looks like. Remember how we talked about that's what natural log looks like. Slow growth. All right, so I think you'll be able to crank out those last ones. They're all just like that. What was the last part? What was part C? What does the shape of the graph suggest? Oh, part CS. What does the shape of the graph suggest about the percentage of older people as time goes on? I don't know. It's going to get slowly bigger. Do they have options? Okay, so let's answer the final. Oh, wait, I thought I had the final question here. I don't have the final question. What happened? Where'd it go? Yeah. Did you guys already answer it? I'm just fooling around on my own here. All right. Yeah, so choose the sentence. So this is the right graph. The expected percentage increases at a slower rate as time goes on. Yeah. All right, so that's easy. We're done. No more. All right, so what do we have here? We have the natural log of 8x plus 50 equals the natural log of 4x plus 18. And they want us to solve. So now, this is a harder section, which I'm sure you're encouraged to hear. We're going to solve some natural log and regular log and exponential equations. This is a little tricky. This will separate some people. I'd be glad to help you. Come see me. I'll be glad to help you. And Roberto, get help. Do whatever help you can. All right. So how does this work? What would be the best way? Okay, I always go back and forth. The easiest way to teach this kind of thing. Let me do this. Let me give you a one-size-fits-all, because I've generally found that students prefer that. If I just give you one way that'll work for all of them. Now, when I do that, realize I'm not giving you the easiest way in every case. Like, there's an easier way to do this one, but you can't do that on other ones. So maybe I'll mention both, but let me just mainly give you a one-size-fits-all. What'll work for everything. So solving logs. How do you do it? Step one. Get the logs, and they go regular log, natural log, it's all the same thing. Get the logs on one side. Get all the logs on one side. Step two. Use the properties, which I'll explain, to make into one log. Now, what do I mean by properties? Adding becomes times, right? Those three properties we just looked at. Subtraction becomes divide. And let me just get this out of the way. Okay, and then step three. Lose the log. Base stays the base. The other two switch, like we learned earlier about losing a log. Natural log base. For natural log, the base is e. For regular log, the base may be 10. Step 4, solve it. Solve it from there, and answers that make the inside of any log negative or 0 in the original discard. That's a lot of writing and fancy talk, but it's not that hard. Step 4 you hardly ever have to do. Everybody good there? So step 4 is just solve. Can you all read that? My chicken scratch up there. So get the logs on one side. Step 1, get the logs on one side. Step 2, use the properties. Adding becomes multiplying, subtraction becomes dividing, to make it into one log. So get them on one side and make them one log. Then lose that log. Base is the base, and the two switch. And remember the bases. Natural log has a base of e, regular log has a base of 10. Solve it. And by the way, throw out the answers that make the inside negative or 0. That's rare. That's rare. Okay, so let's do that on this question. So I'm going to go to a new page here. And let's do this one. All right, so I'm going to go through the steps with you. So step 1. The LN's on the same side. So grab, so you've got LN, up here you've got LN of, no, I don't like writing way over here. bugging me. Here, let me go over here. So we got ln of 8x plus 50 equals ln of 4x plus 18. So step 1, pull this over here. The logs, you got to get them on the same side. So log of 8x plus 50 minus ln of 4x plus 18 equals 0. Step 1, same side. Same side. So we get the two logs on the same side. Step 2. What's step 2? Combine them into one log. This becomes ln of 8x plus 50 over 4x plus 18. Step 2. Combine into one log. Subtraction becomes divide. Adding becomes multiply. Remember that? I know this is where we're moving fast. Because normally when I teach intermediate, I teach all this in intermediate algebra, but I spend a week with those properties. And then after they've digested them and done homework on them, I go, all right, now let's use those properties to do something bigger. But you guys, we just saw it 20 minutes ago. All right, so we're using those properties now to solve these equations. Do you see why this subtraction became divide? Because that's the property. Easier operation for 2 logs, subtraction, becomes a harder, divide is a higher level operation, right? For 1 log. That's the properties we just saw. If that had been adding in the middle originally, what would I have done here? Times. Would have been 8x plus 50 parenthesis times 4x plus 18. Remember, adding becomes times, subtraction becomes divide. Adding becomes times, subtraction becomes divide. All right, so that's step 2. And now, step 3, you're going to lose the log. One thing I can say, it seems like a million steps and everything. One thing I can say to really help you remember all these steps is I call it a log countdown. I think that's helpful. So in other words, look what we're doing. We're counting down the number of logs. 2 logs on this line, 1 log on that line, next line, no logs. 2 logs, 1 log, no log. That's how this flows. 2 logs, 1 log, no log. What do I mean no log? Well, now, step 3, I'm going to lose the log, the ln. And what happens when you gain or lose a log? Remember what happens? Base stays the base. Other 2 switch. So I'm going to lose that log. On the next line, there will be no log. The base stays the base. Now, what's the base? What's the base for ln? E. So go ahead and write it in there. It's an understood base. We need to see it, though. So write in that E. He's really been there all along. Every log really has a base. If they're not showing their base, you fill it in. So his base is really E. If that was the regular log word, what would his base be? 10, right? So ln is base E, regular log is base 10. Cross out the log, lose the log, base stays the base, so the E will be the low down one. He will continue. Remember, he's just a special number. He's 2 point whatever, whatever. Just like pi is a special number, 3 point whatever, right? So E is the base. The other 2 switch. The base stays the base. The other 2, what other 2? Everything else. This whole big old fraction thing and the 0. They switch positions, right? Base stays the base. Whenever you cross out a log, base stays the base, other 2 swap. So instead of E to that whole fraction thing, it's E to the 0. And that whole fraction thing goes to the other side where the 0 was. Good to there so far? We have no more log now. Notice, we had 2 logs, 1 log, no log. So I call it log countdown. 2 logs, 1 log, no log. Okay. Now, what do you remember about algebra? What's E to the 0 power? What's anything to the 0 power? That's 1. E's just a special number. So it's just a number. Okay, so we got that. Now, how do we solve? Now we're on step 4, which just says solve. So how do we solve this? Do you remember in your algebra days when you have a fraction on one side and a whole number on the other, how you solve it? Yeah, put this one over 1 and go diagonal, diagonal. Cross multiply, remember that? About the easiest way to go. So I'm going to move that to the other page there. So what is that? 8x plus 50. So 1 equals 8x plus 50 over, what was it? 4x plus 18, okay. 4x plus 18. So put that over 1, diagonal, diagonal. Like that. Diagonal, diagonal. We're getting close. Distribute, so 4x plus 18. Those ones don't really do anything, do they? 8x plus 50. We're almost there. How do we solve for x? What do you do when you have a wall, you have x on opposite sides? Get rid of one of them. I usually just get rid of the lower one. So subtract 4x from both sides. I would subtract 4x from both sides. You could subtract 8x. That would work too. It doesn't matter. Just get rid of one of them. I usually subtract the lower one. So now we get, what's this? 4x plus 50. Right? These two made 4x. And we're almost there. X is almost alone. Subtract 50. And what do we get? Minus 32. Like that. You can use your calculator for all this stuff. And there it is, negative 8. Whew, that was a lot of work. So x is negative 8. Did you follow all those steps? Questions I can answer?
We don't discard the negative 8 there then?
Yeah, now let's talk about that fourth step that I gave, where I said, hey, no negatives. Well, it didn't say no negatives. If you look back, what it said is, if you plug that into the original, it can't make the inside of any log negative. Negative answers may be okay. I think this one might be. I'm not sure. Let's go back and check. Here's how we check. I'll do the check right up here. Check. You guys have the original? Here, I'll go back. What was the original? It was ln of 8x plus 50. ln of 8x plus 50. And the other side was ln of 4x plus 18. 4x plus 18. That means x equals negative 8 if plugged in cannot make the inside of any log negative. Let's plug it in. Put that negative 8 in right there and put that negative 8 in right there. If you put it in right there, 8 times negative 8, that's the inside, right, is negative 64 plus 50. Oh, it's negative. So forget it. It's out. So if the inside, so there's no answer, no solution. This one has no solution. All that work, no solution. So if the inside, now if this had been something just like negative 1, it would have been okay. It would not have made that inside negative, or that one. Right? You can check it on your calculator. If you take the log of anything negative, it'll go eh. It'll just, well, it won't make a noise. It'll go air. It'll just say air. You can't, or 0. You can't make the inside 0 or negative of a log. It chokes on those. Only positive numbers can be the inside of a log. So your answer, when plugged into the original, cannot make the inside negative or 0. If it does, throw it out. So that one's a no solution after all that work. That seems like a ripoff. Is that really right? I feel like we messed up. Let's go back and check. Okay, so there we go. So try that out. So I'll write it up here. Natural log of 9x plus 13 minus natural log of x equals natural log of 10. So, first step. Remember these steps? What's our first step? Okay, the log's on one side. So jump that natural log of 10 over. While you're working, can I introduce Roberto? Roberto, you raise your hand or stand up or whatever you want to do, and I'll write on the board your hours. So maybe I could write up there and it'll just stay up there. Think? What if I write back here? Think? We'll see what they do. I'll say, please. Please save. So Roberto is our ETC tutor, which means extending the classroom, right? So he's like an extension of what happens in here because he'll be dialing in with me, seeing the ways I present things, and so he won't show you a different way. When you go to, he'll have my practice exams. Well, that's right. I didn't send you those ones too. I sent you the pre-calculus. Yeah. So anyway, he will. Well, 2 weeks from now for exam, so we have 2 weeks to go. So what are your hours, Roberto?
Only I think Tuesday after class, so 3 to 4:30.
So you're going to schedule in there after class.
That's pretty much. And I'll be here after your class on Thursday, but I mean they didn't schedule on there.
Okay, let me just put that in.
Just after your class.
What is my class on Thursday? It ends at 3.
Yeah.
Oh yeah. Same. After this class?
Yeah, I was just
Or,
there. Okay. I can answer the questions after class, but really only Tuesday was the only one that we were able to schedule in there.
Oh, gotcha. So
Yeah.
you're officially only Tuesday. Okay.
Yeah, but
So we'll just hear it now. But
I'll be
now you're over there other times though, right?
yes.
When are you over there even for other classes? How about that? Is that okay? Did I write that in? This is when you're
Sure.
officially Math 21, right? But you're over there at other times.
I can update it if you want. You can continue with that.
Okay,
I'll just
sounds
add it on there.
Sounds good. Yeah, so please go see Roberto. He works with me. He'll be a big help to you. I begged and pleaded. He wasn't assigned to this class. He was assigned only to all my other classes, including my Math 201, which is basic algebra. And they never come for help. Ever. Ever. I don't know why, but they never, ever. And I've taught this class before, and you guys need help. At least you're a little bit more mature students, is the truth. And you realize you need help, and you go get the help. That's been my experience. And the basic algebra students, they don't want help. They don't care about math. So, or they don't care about graduating. I don't know what they care about. But they don't care about doing well in that class usually. So I begged and pleaded, and the department changed and gave him those hours. So he's there for you guys. So take advantage of it. All right. So let's bring these things all over to one side. So natural log 9x plus 13 minus natural log x minus natural log 10. So step 1, logs on the same side, right? Step 2, now it's log countdown time, right? We're going to go right from 3 logs to 1 log to no logs. 3 logs, 1 log, no log, right? We're going to count them down. How do these 3 logs become 1 log? Anything subtracted is divided. Put the 10 and the x on the bottom. Did I just confuse you? Both the x and the 10 are subtracted, which means they're both denominator. Anything, now if that 10 was multiplied, was added, then I would have put the 10 on the top like that. Does that make sense? The order doesn't matter. Don't look at the order and think, oh yeah, but the x is before the 10. Order matters not at all. Order matters not at all. Anything that's a positive in the front, the first one has a positive really in front of him. Anything with a positive in the front goes to the top. Anything with a negative in the front, subtraction, goes to the bottom. Subtraction is division. Adding is multiplication, top. Multiplying is another way to say top. I don't know if you think that way, but that's right. Multiplying just means top. Dividing just means bottom. The order doesn't matter. Does that make sense? So let me say it right now since I goofed it all up. So anything subtracted goes to the bottom. Anything with a negative in front of it. You can put x10 or 10x. Again, order doesn't matter. We're used to seeing it as 10x, so I'll do it that way, but it's fine either way. Anything subtracted is denominator. Anything added is numerator. All right, so 3 logs to 1 log. That's step 2. Step 2. And now, next step, lose the log. Right? We're counting them down. 3 logs, 1 log, no log. How do you lose the log? What happens? What's the base? E. When you lose the log, base stays the base. Other 2 swap. Instead of e to all that messy x stuff, it's e to the 0. And that big old x fraction goes over there. That's step 3. Lose the log. That good? That's going to be just like last time then. E to the 0 is 1. This is 9x plus 13 over 10x. Put it over 1. Diagonal, diagonal. Cross multiply, right? Okay, can I go 1? So 1 equals 9x plus 13. 1 equals 9x plus 13. What's that? 13. Come on. Over 10x. Put it over 1. Diagonal, diagonal. So 1 times 10x. 1 times 9x plus 13. So this is 1 times 10x is that. Boom, boom. 9x plus 13. All right, how do we finish solving for x? Subtract 9x. Boom. X equals 13, maybe. Does it make the inside of any log 0 or negative? I don't think. It's probably fine, right? You can go back. I don't know. I don't remember. It's fine. Yeah, so I don't want to use up a lot of time. If you plug it into the original insides, it doesn't make any of those insides 0 or negative. Right here, I'll just show back to you. If you put a 13 in there and a 13 in there, 9 times 13, add 13. I don't know what it is, but it's not 0 and it's not negative. Right? It's a really quick thing. The check is super quick. Just make sure it's not 0, it's not negative. You plug the answer back into the first step for x. Just make sure the inside is not 0. And what's 9 times 13 plus 13? I don't know, but it's not 0 and it's not negative. put it in here, natural log 13, that's not 0, not negative, just the inside. So it's really quick. You can usually just glance at it, and you know whether it's good. Is that okay? That makes sense? Am I doing that too quick? So the answer is the 13 as our keeper there. Now, there is an easier, I did this one the hard way. This is like what I'm saying. There's actually an easier way to do this one. And I'll be glad to show you after class if you want to see an easier way. But the reason I do this is because what I'm showing you now will work for all the problems. It'll work for everything. There's an easier way to do these ones that have logs on both sides. You can really drop the logs after you do a certain thing. But rather than confuse you, that would be quicker on these last two. But I just want to show you this one size fits all. This will solve any log questions. All right. Okay, so number 3. So log base 2, this will be easier. 5x minus 9 equals 1. And want me to solve it.
Can we just plug that in the calculator?
How can you put an x in your calculator? Got to have straight numbers. Yeah. All right. Just jump right in. Remember that step 1 said, what does step 1 say? Get the logs on one side. Well, they already are. Usually you can skip step 1. In fact, you'll probably never have to do step 1 again. Those last 2 problems are the only time you have to get the logs on one side. They usually are. So step 1, logs, same side. It's done. It's already done. There's nothing to do. Step 2. What's step 2 say?
Get rid of the log.
Combine them into one log. Well, it already is one log. Step 2, done. So now step 3, lose the log. Yeah, so just think in your mind, just think, eventually I got to get rid of the logs. That's really what we're doing, huh? So if there's like lots of logs, get them on one side, use the properties, make them 1, and then lose that 1. You get the game plan? It's just always about getting rid of the logs. You got logs in there, you want them out of there. So we've only got 1 log, so just lose him right away. Just lose that log. What happens when I lose the log? Base stays the base, the other 2 switch, which means the whole 5x minus 9 and the 1 switch. Instead of 2 to the 5x minus 9, it's 2 to the 1. 5x minus 9 goes over there. No more log, right? That's what it's all about. These log equations are all about losing the log. And now 2 to the 1, that's just 2. How do you solve for x? Add 9. Divide by 5. 11/5. We are done. You can check it. It checks. If you want to put the 11/5 back in here. What is 5 times 11/5? Well, the 5's cancel. It's 11. Minus 9 is 2, is not 0, is not negative. So it's a good answer.
You put it in 11 bits, you divide 11 by 5.
They say fraction. See the blue line? Yeah, a test, I don't care. Decimal fraction, whatever. But yeah, they'll tell you what they want. They want the fraction. But yeah, the test you want to divide that, get whatever it is, 2.2 or something. Then that's fine too. Questions on that? We good? So that was easier, huh? Okay, so number 4. Log x plus log x minus 2, no, x minus 21 equals 2, huh? Okay, so try that one, same thing. It's all about gathering those logs up and then losing the log. So gather up the logs and lose the log. Is that making sense? So the way, when you see these log ones, you should think, okay, it's a log countdown, right? 2 logs, 1 log, no logs. So you're looking at 2 logs right now. 2 logs, 1 log, no log. So next line, you should have 1 log. Line after that, no log at all. So just remember that phrase. It's a log countdown. 2 logs, 1 log, no logs. So 2 logs, 1 log. How do you make these 2 into 1?
Log.
Adding. What does adding become? Times. Remember that? That becomes times. If that was subtraction in the middle, I would put x over x minus 21. It would be divide, huh? So adding is first times the second. Subtraction is first divided by the second. Right? Is that making sense? Remember, adding and multiplying, those are like operations. They both make things bigger. Adding goes with multiplying, right? Subtraction and division, they both make things smaller. They go together, right? Makes sense? So 2 logs, 1 log, next line, no log, right? It's always a countdown. Even the last problem, the last problem just started with 1 log, so we went right to no log, huh? So you're always thinking log countdown. So how do I go to no log now? Well, I lose the log. And what happens when I lose the log? The base stays the base. The other two switch. What's the base? 10. Good. The base is 10, isn't it? They're not. This is a regular log word. So his base is 10. A couple problems ago we did natural log. That base was e, right? So ln has a base of e that it doesn't show. Regular log, if he doesn't show his base, it's 10. All right, it's called the common log. It's the one most commonly used. All right, you cross out the log, the base stays the base, and the other two switch. Instead of 10 to all that x stuff, it's 10 to the 2, and all that x stuff goes to the other side. Now we just solve it. 10 squared is 100. X squared minus 21x. Uh-oh, now what? Yeah, do you know what to do when you see x squared? Let me go over here. So 100 is x squared minus 21x. Did you guys get that all copied down there? You okay there? Yeah, so as soon as you see x squared, remember we talked about this a week ago, and you guys never forget anything we say in here, right? Get a 0. I know I say a lot. I talk fast at you for an hour and 15 minutes twice a week. And whenever you see x squared with an equal sign, step 1 is get a 0. Step 2 is factor with the parentheses, you know. So as soon as you see x squared rear its ugly head, you think, get a 0. Get a 0. Again, that's algebra 2. So I know it's not on the top of everybody's mind. So that'll become 0 equals x squared minus 20x minus. I pull it that way because you want the x squared term to be positive. See, if I jump the x squared stuff to the other side, then the x squared will become negative. Remember, when things jump over the equal sign, they change signs, right? I'm really just subtracting 100 from both sides, right? Just doing a shortcut. Does everybody make sense of that? You don't want to jump x squared to where he'll be a negative, because that's hard to factor with the front term negative. So jump everything to whatever side where the front term will be positive. It's just easier. So then we factor. Now, I know that factoring is rusty for many people. Roberto loves to factor with people. I'm sure he does. Roberto's an excellent mathematician. He's very helpful. He will help you with all this. I'm glad to help. I know people are rusty here, but I have to go fast. So write FOIL, first, outer, inner, last. What multiplies to be 10? Front times front makes front. That's what the F stands for in the word FOIL. And last times last makes last. What times what's 100? Well, a lot of things. 10 times 10, 5 times 20, 4 times 25, 2 times 50. How do you know which one you want to use? Yeah, they got to somehow make the 21. Those two, huh? 4. You can put them in any order, but yeah, the sign in the middle has to go on the bigger. Everybody hearing me on that? That's important if you're a little rusty on factoring. Sign, middle sign, right there, that minus sign right there, has to go on the bigger. Who's the bigger? The 25. Right, because negative 25 plus 4 is negative 21, isn't it? The sign in the middle will always be taken by the bigger. All right, now, where do you go from there? Remember, each one gets its own 0. Do you remember that from your algebra days? Why? Because if two things multiply to be 0, either one can be 0 to make that true, right? If I was saying to you, hey, I'm thinking of two numbers, and I multiply them in my head, these two numbers, they times out to be 0. What does that mean about my numbers? How can two numbers multiply to be 0? What do we know about one of them?
0.
One of them's got to be 0, right? If they're multiplying each other and the answer's coming out 0, that's what this is saying. this times, right, parentheses, this times this equals 0. These two things are timesing and equaling 0. What does that mean? Either the first one could be 0, this one, because 0 times anything would be 0. Or the second one can be 0, because 0 times anything would be 0. Either one could be 0 to make that true, right? And so then we jump that over, so we get -4, +25. Two answers, maybe. I don't remember what the original was. What was the original? We just got to go back and plug them into the original. Let's go back. So -4. If I put the -4 back in the original, no. It's making the inside of those logs negative. Throw it away. What was the other answer? So throw out the -4. What about the 25 is probably good, right? If I put 25 in here, even this one, 25 minus 21, still +4. So that's a keeper. That keeps the inside of the logs positive. So the only answer is 25. You throw out the -4. +25. Is that good? It's making sense.